Introduction. Computer use a fixed number of bits to represent a piece of data. If we take a n-bit storage location, it can represent up to 2 power n distinct elements. If we take a 3-bit memory location, it can represent 8 patterns. If we take from 000 to 111. These entities can be from 0 to 7 numbers or numbers from 8881 to 888 to 8888 or characters from A to H. Today's topics. Today in this lecture we will see how to convert a fractional number to a binary number. Let us take a fractional number 19.25. First, we will write these decimal and fractional numbers separately, 19 and 0.25. This 19 number we will convert to binary in normal procedure. 19 when that with 2, 9 remainder 1, 4 remainder 1, 2 remainder 0, 2 remainder 0. Now writing from bottom to top, we get 19 when converted from decimal to binary, we get 10011 to the base 2. Converting from fractional part to binary is different. We write 0.25 into 2. We get 0.50. As the decimal part is 0, we take it as 0. Next, we write 0.50 into 2, we get 1.00. As the decimal part is 1, we take it as 1. Next, 0.00 into 2, we always get 0, so we stop here. So writing from top to bottom, we can now represent 19.25 of decimal part into binary as 10011.01. We have completed the conversion of fractional number to a binary number. Now let's go to how to represent an integer number. Integer number can be represented in two formats, unsigned integer and signed integer. Coming to unsigned integer. Unsigned integer can be used to represent numbers from 0 and positive numbers or natural numbers. The magnitude of the binary pattern represents the absolute value of integer. Let us take an example 0, 1, 00, 111, 1. Here the magnitude of this number represents the value of the integer. As it is the first position, its value is 2 power 0, and this value is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5 and 2 power 6. So its value will be 65. D. Now let us see the range of the unsigned integers for the given value of n. If the vector length or bit length is 8, the unsigned integer range will range from 0 to 2 power n minus 1, which is 0 to 2 power 8 minus 1, which is 255. If we take n is equals to 16, we get from 0 to 2 power n minus 1, which is 0 to 65,531. Similarly for 32 and 64. Representation of integer. In signed integer representation, the most significant bit or MSB is the signed bit. If the most significant bit is 0, it represents a positive number. If it is 1, it represents negative number. The magnitude of remaining n minus 1 bits binary pattern is the absolute value of integer. The sign integers can be represented in three formats: sign magnitude representation, ones complement representation, and 2's complement representation. Coming to sign magnitude representation, as we have said, the most significant bit represents the sign bit. As it is 0, it represents positive number, and the remaining n minus 1 magnitude of n minus 1 digit represents the magnitude of the integer, which is 65. So the value of this number represents plus 65d. Now let us take another number, 1000001. The most significant bit is 1, so it represents negative number. The remaining n minus 1 digits represents the magnitude of the sign number, which is 1, so it represents minus 1d. So coming to the limitations of sign magnitude representation. In sign magnitude representation is not preferred because we have two representation of number 0. This number represents negative 0 and this represents positive 0, which could lead to inefficiency and confusion while evaluating the problems. The second drawback of this sign magnitude representation is that the positive and negative numbers should be processed or evaluated separately. Thank you. In the next lecture or tutorial, we will discuss one's complement and two's complement. Thank you.